To multiply and divide rational expressions, you will use the same rules that you use to multiply and divide fractions. For example, if multiplying these fractions, 10 over 35 times 7 over 15, the general rule is to multiply the numerators 10 times 7 and the denominators 35 times 15. You do not need common denominators when multiplying and dividing rational expressions. To make this a little bit easier, instead of multiplying the top and the bottom first, we can reduce common factors out of both the top and the bottom. So for example, 10 and 15 have a common factor of 5. 10 divided by 5 is 2, and 15 divided by 5 is 3. We can do the same thing with 7 and 35. 7 divided by 7 is 1, and 35 divided by 7 is 5. Now we can multiply across the top and get 2, and across the bottom and get 15. This now gives us a final answer and completely simplified. We'll do the same thing with rational expressions containing polynomials. Instead of trying to multiply x plus 2 times 5x minus 15, we'll factor first and see if there are any common factors that we can cancel out. There's nothing we can do to factor x plus 2, so we'll leave that as is. For 2x minus 6, we can factor out a 2, giving us 2 times x minus 3. For 5x minus 15, we can also remove a 5. So we have 5 times x minus 3. And on the bottom, we have 3 times x plus 2. Now we can look for any common factors that we can cancel out. We can see a common factor of x plus 2 and a common factor of x minus 3. If we look at the remaining numbers, there are no other common factors that we can divide. So now we can multiply across the top 1 times 5 times 1, which gives us 5, and 2 times 1 times 3 times 1, which gives us 6. So our final answer is 5 over 6. For a little bit more complex of a problem, we'll do the same thing. For the top polynomial here, we can factor out an x, giving us x times x minus 2. 2x squared plus x minus 15 is a little bit more complicated to factor. Remember that the two binomials have to multiply to give you 2x squared, giving you the only option of 2x times x. Factoring this polynomial, if we make this minus 5 and here plus 3, we can see that this makes these outer terms 6x and these inner terms negative 5x. We know from factoring that the outer terms and the inner terms must combine to be the middle term, and that will give you positive x. Remember that the 5 and the 3 come from the fact that these two terms at the end must multiply to be 15. Sometimes there's some trial and error associated with these. The same thing goes with 2x squared minus x minus 10. Again, we have 2x times x, and we need the numbers at the ends here to multiply to be 10. There are several combinations that we can try. The ones that will work are 2x minus 5 times x plus 2. The denominator is a difference of perfect squares, so the factors will be x plus 2 times x minus 2. Now we can look for common factors and see if there's anything we can cancel out before multiplying. Here we see a common factor of x minus 2. We here see a common factor of 2x minus 5. And within this fraction, we also have a common factor of x plus 2. Now we found all the common factors. There's nothing else that can be canceled. So we're going to multiply across the top, x times 1 times 1 times 1, so just x. And across the bottom, 1 times x plus 3 times 1 times 1, so just x plus 3. Remember that the x on the top and the x on the bottom cannot be canceled out here. The only things that can be canceled out are factors, and x is not a factor of the denominator. To divide rational expressions, remember the simple rules for dividing two fractions. For example, 3 over 5 divided by 10 over 7. When we do this, we have to change this to multiplication. So we keep the first fraction as 3 over 5, and when changing to multiplication, this flips the second fraction over. So where it looked like we might have some things that would cancel out, we actually don't. There are no common factors between 3 and 5, or 7 and 10, or 3 and 10, or 7 and 5, so we're left with just multiplying the top to give us 21, and the bottom to give us 50. Since we couldn't cancel anything else before, we know that would be our final answer. So division is very similar to multiplication. The only difference is that you have to change division to multiplication first. So in this example, we will recognize that this is division and keep the first fraction the same. Change to multiplication and flip the second fraction over. Remember that we're now looking for common factors. So we can factor the numerator by using common factors. 12x and y squared go into both terms. This means what we're left with on the top is just x minus 2. The bottom is a monomial, so there's nothing we can do to factor that. We'll just leave it as 5z squared. The same goes for the numerator of the second fraction. The bottom fraction has a common factor of 4x squared y. After we take 4x squared y out of this first term, we're left with x, and out of the second term, we're left with only 2, because we took the x squared and the y out, and 8 divided by 4 is 2. Now that everything's factored, we can look for common factors and cancel them out. We can see that x minus 2 is definitely a common factor. We also have several monomial factors that will cancel. So for instance, if we look at everything separately, we can cancel 4 because 4 goes into 12 3 times. We can see that x is present here and here. So x cancels out here and here, and we're left with an x. The same goes for y, however, we're left with 1 on the bottom and a y up on the top. For the z's, this was z to the 4th. We can cancel z squared and z to the 4th. Here we're left with z squared. Notice that 5 and 3 do not have any common factors. Even though we have 3 here and 3 here, they're both in the numerator, so we can't cancel those. So it looks as if we've gotten all of the common factors, and we now need to multiply the numerators and the denominators. So we have 3y, 3 times 1 times y times 1 times 3 times z squared. So the ones aren't factoring in, but we have 3 times 3, which is 9, y, z squared, and on the bottom, 5x. Everything else canceled out to be 1. And now that this is all together, we can see that this is completely simplified. Looking at one more problem. This is again a division problem, so the first thing we're going to want to do is change it to multiplication. When we change to multiplication, we flip over the second fraction. Now we'll need to factor all of these expressions. So x squared minus 8x plus 15, the factors are x minus 3 and x minus 5. X squared plus 2x minus 35 becomes x plus 7 times x minus 5. X squared plus 9x plus 14 becomes x plus 7 times x plus 2. And 15 minus 2x minus x squared is better factored if we first pull out a negative 1. When we pull out negative 1, we now have negative 15 plus 2x plus x squared. This can be rewritten now as x squared plus 2x minus 15. It's much easier to factor that with the x squared positive and listed first. If you see a negative x squared term, it's best to factor out a -1 to factor that. It will make the cancellation later on easier as well. So now that this is -1 times x squared plus 2x minus 15, we can factor this and get x plus 5 times x minus 3. Don't forget about the -1 in the front. So now we can cancel out all of the common factors we have. X minus 3, x minus 5 in the same fraction, and x plus 7. So now we need to multiply the numerators and the denominators. On the numerators, all we're left here with is x plus 2. And on the bottom, we have -1 times x plus 5. We shouldn't leave the -1 in the denominator. So what we will do is we will write this as negative x plus 2 over x plus 5. It's important to note that the negative is in front of the fraction and not with the x plus 2 or the x plus 5. It could be distributed to the numerator, but it's best to leave it in front and separate.